You know, I've been showing my stuff here for years and years, and I have so much evidence it cannot be disputed. I have DNA reports, I have CAT scans, I have the light experiments, I show the particles. Everything is above board and scientific, and to scientific people from Yale and Harvard and Johns Hopkins and all of the universities, anyone that's speaking, I have tried to contact, they refuse to speak. Is free speech under attack? Absolutely is. The kids are not all right. They should be looking for their money back, to be perfectly honest with you, because they can't speak. Free speech is under threat. Yes, it is. CBS reports looking at it. More than 2/3 of the college students say the atmosphere on campus inhibits them from voicing opinions or views. They want to know, they want to interact, and they can't. They just have to repeat. We reached an inflection point between fear is silencing the effect and it cripple intellectual curiosity and discourse. That's already happened. Let me show you something at Yale. Okay, my friends, my contention is that the standard model is not correct, and we did light research and actually saw the particles, the same ones that Fermilab sees. You see these Fermilab particles, the big black one and this one, and Don Lincoln talks about it, and I'll probably show you his articles about it back when we were first looking at it in 2013, 2014. Now, here's the particles that he's talking about, the big black one with the little glowy around it, and the two little point particles that have literally no mass. I agree with what he's saying. It's just that he doesn't agree with what he's saying. Now, and I'm not kidding you. These are photons of light, and here they are being emitted from a red pulsed laser. Boom, 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 boom. And here, all of a sudden, because we put them through a Venturi, they had to accelerate. When they did, they had to crush their fields. And every particle, instead of protons being one big chunk of matter and being able to be smashed, because you can smash it. And when they smash it, they see the muons and the electron neutrinos, exactly what I showed you, the muons and the electron neutrinos. We could see them when they were together as that four particle. Here it's glued together. It's what they would call a gluon. They're gluoned together. They're glued together. And then when they concuss at the Venturi, right here, they actually divide. So the black little balls come away from the white, and the white turns into showers. This is what Fermilab put out. This is not me. They say, here they come, the black one and the white one. Black one and white one's together. All of a sudden, when they hit something like heavy water, the black one stays black because it's a fixed particle, as Don Lincoln says. And the electron one turns into electron shower because it's a point particle. And I have shown this exactly identical to what CERN is asking for. This is what CERN says right here, and Fermilab. And this is what we did, is exactly that. So as far as I'm concerned, this is fission. They broke apart. This is fusion. They came back together. This is like a bazillionth of a second because it's only from here to here, and we're right up on top of the event with literally a smartphone. And this was done 7 or 8 years ago. And they knew about this at the same time. Cornell was looking into this, Fermilab, the University of Geneva. I went there for particle physics, and I showed them all this stuff, and they took it right in. They said, wow, this is pretty amazing. The next thing I know, they shut down CERN to make their stuff focus. It just came back online. I'm not kidding you. All right, I keep talking about free energy, and look at this. This goes back to 2013, 2014. 2p, 2h particles with interactions up to 10 billion electron volts. That's these 2p's and 2h's. The holes are the black ones, and the p's are the particle ones. 2p, 2h. Neutrino nucleus. And they just dropped it. Same thing here. Don Lincoln from Fermilab at work. Well, they show the same particles I'm showing. That's the one little point particle that squishes down. It doesn't have any impact value other than burning. That's the one that hits the houses in the atomic bomb blast and just burns it up. And then these come, and the house goes flying. This is from Don Lincoln, 2013. All right? It says, in summary, extended particles have a fixed size. That's the black one. Then many have a fuzzy edge. That's the white, glowy edge around them. Yes, absolutely. The point-like particles are abstractions with zero size, and I can pretty much agree with that. But even zero-size particles have an extended effect due to the effect of the field surrounding them. Well, there has to be something to be surrounded by, so I can't go with zero, but I can go with almost nothing. And again, there's Don Lincoln. And here's Don Lincoln again, I think. Quantum foam, yeah. Here's where the same time frame, he says, yes, the space is completely saturated with quantum foam, which is the light particles and all the electrons. Quantum foam is real. The microcosm is in continual motion. That means there's nothing but particles continuously everywhere. The universe is not only stranger than we imagine, it is stranger than we can imagine. And you can't even imagine that, my friend. That's Don Lincoln again. And this is the government. Now, I've tried to interact with all these people. I just can't get through. Okay, my friends, are you ready to have fun? Because I am. Department of Energy explains muons. Now, this is Fermilab. They're going to do all kind of particle physics and stuff. A muon weighs more than 200 times as much as the electron portion. A muon and an electron are together as a muon and electron neutrino. I'll show you that in a second. You see down here? They're neutrinos. Now, the muon is part of the lepton group. We're going to look into this in a second. Leptons are a type of fundamental particle. That means the smallest there is. They're fundamental. This means they are not made of even smaller pieces of matter. So, a muon is not made of anything smaller, or is an electron. But an electron and a muon are both neutrinos. See down here? Okay, they're just thinking muons are neutrinos. No, electrons are also neutrinos, and they turn into showers. Let me show you Fermilab's explanation of what they look like. Now, listen to this. It says, Department of Energy Sciences has a long history of supporting research into fundamental particles. All right, now I'm trying to get them to look at my stuff. They won't look at it. And that's Fermilab won't look at it. Much of DOE's research into the muons have been through different versions of this G2 experiment. Billions and billions of dollars. Currently, Fermilab is doing this. The research began in the 50s, so we got like 70 years of never finding anything. Now, I'm showing you the muons and the electron neutrinos. This is no question what they are. Here's the key. They missed what a muon is. They think a muon, they're taking it for a photon. It's not, because here's what they say. The muon exists for only this very short time frame before they decay into an electron and two kinds of neutrinos. Well, it's actually electron neutrino and a muon neutrino. The muon, as far as I'm concerned, they must be talking about a photon. It seems apparent to me that they just are mixed up. This is a photon of light. All right, and that is what's coming here in this beam, is what this light picture was taken out of. And this is enhanced to show the energy values. And these are the two fixed particles. They're just big bang black bangers. And these are the little squirters that are the things that burn a house when they did the nuclear bombs. And then the next thing that would come was the black particle and just blow the house away. So they can separate, and we did separate them, and here we did separate them right there. There's the black ones separated from the white, because we crushed their fields. So it's obvious they're talking about a muon neutrino and electron neutrino. Now they said they divide into these two types of neutrinos. So they have a muon coming in, they think. It's not. What they had coming in is this right here, a photon. They didn't realize it. They had a photon coming in which splits off into a muon and an electron neutrino. Or actually two sets of them. The two P2H particles that, well, hold on. All right, here it is right here. I'm just saying these are the only things that exist. Are the smallest particles everything is made out of. A photon is that little 4 particle. All right? Scratch all that stuff. This is just more and more and more pieces of the small ones spinning this way, spinning that way, and so forth. Now, in different colors. Now, here's what they are. Everything is made of these 2 particles. And that is the muon neutrino and the electron neutrino. The only thing that exists. The only thing. When they add together, 2 of them side by side, like 2 little bar magnets, you have a photon. And Cornell called it the 2p2h, 2 holes and 2 particles. Don Lincoln calls it the black fixed particle and the point particle. Now he's seeing these from the collisions, yes. And they see these too. And then they see all these other things. And they think, oh, we see all those so often, they must be elementary particles. Now listen to what it says here. Physicists have been here before, because now they're saying there's a chink in the armor. Here, hold on. Here's how it starts out. Higher W boson mass hints at chinks in the standard model. So they know the standard model's been wrong. I've known it's been wrong since 1970. Now, they've been here before, exciting new physics, only to have their hopes dashed. As more evidence came in, extraordinary claims require extraordinary evidence. Well, extraordinary evidence requires looking at that extraordinary evidence that proves the extraordinary claims. All right, you need a couple more extraordinaries in here to balance off your other extraordinaries. Now, this is definitely an extraordinary claim. My claims are extremely extraordinary, but they are backed up by extremely extraordinary evidence. If true, it's the most important because the standard model would be wrong, which it is. Clifford Chung, a scientist at Caltech, told ours, but the clear disagreement in experiments warrants immense caution. Well, don't be so cautious that you don't look. These are the particles that exist. The photon is that photon right there. What makes that photon is these gluon particles, which is the W and Z bosons, and they create the Higgs fields and all that stuff. But it's only from here down. All the stuff added back together. So an actual proton is like this. And it just breaks into smaller and smaller pieces, and every piece is a little bar magnet glued together. So I think I've just solved the whole issue here. And everything works once you go into the dipole flood theory. Because you can't have one gigantic positive in the center, one tiny little negative. Why would it stay out there? Nothing ever did work. And they had to go through such mental gymnastics that make people insane. But they have to keep saying what they're told to say, or they have to just shut up. And the kids can't speak up. You see this? The kids are just nothing more than indoctrinated little robots now. Are they right? Can they speak up and have free speech? No, they cannot. CBS reported on this. More than 2/3 of college students say the atmosphere on campus inhibits them from voicing opinions and views. That's not good. All right, so this is the Department of Energy on their neutrinos. Let's see what they have to say about neutrinos. All right, Department of Energy explains neutrinos. Neutrino, perhaps the best named particle. It is tiny, neutral, which is not true, and weighs so little that no one has been able to measure its mass. So I can't measure it, but I think I know how much it weighs. As both of these both of these particles together are neutrinos. The muon and the electron, they're both neutrinos. One's black and one's glowy. And it could be green, it could be blue, it could be red. I think there might be a whole bunch of other different colors depending upon the frequency that it spins at. We had red, green, blue, and they all were the same. Now, so that's what I call a neutrino. But they're one of 2 flavors. There's the muon and then the electron, which broke down to create showers, and the black one stayed the fixed particle. I think I've shown that before, or you certainly will see it. Now, so No one's been able to measure the mass of it. Well, I can tell you what, it weighs approximately 1839. Let's put it this way, 1839 of these neutrinos make up one proton. The weight of one proton is 1839 neutrinos. And each neutrino consists of the muon and the electron, black and white ball. So I claim that it weighs, I think it ended up weighing out 0.005854, something like that. Divide 1 by 1839, it's in that area, somewhere around there. Not much difference. And a proton is a charged particle, which means it's a positively charged particle. It wants to take in one more electron to become a neutron. And if it does take on one more electron, it will become a neutron. And it weighs exactly the difference between one more electron to become a neutron from a proton. It's extremely obvious when you start to look at everything. So they say it's tiny, it weighs so little, no one's been able to measure it. Well, I think I just measured it. Neutrinos are most abundant particles. They make everything there is and have the mass of the universe. Every time atomic nuclei come together or break apart, they produce neutrinos. No question, that's true. So anyway, these are the particles I just showed you, which are the neutrinos. All right, one last time. I mean, I know I'm beating this thing to death, but if no one will look, what do? This is Fermilab. Once again, they show that glowy particle right there, the point particle, which just has a theoretical mass, and it could have no mass, I agree. This one is a bomber, and it has a little glowy ridge around it, which is the bomber with a glowy ridge around it. This one's going forward this way. Light is going this way. You see it's concussing here, that's why that's glowing. That's going to charge up and flip. That's a muon wobble. This is the discharge one. That'll come to the front and charge, and then it'll flip again. Flip, 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 flip. That's what they do. And they do it very, very, very fast. So even though we're seeing it in its entirety here, and we will see it again coming here, looking like this, one right after the other. It's all one picture, but you'll see like 2 or 3 different particles all in a row, but the same particle. It's just that it's all happening so fast you see them separate. The camera has like a little brrr. Now, again, these are the muon neutrinos, and these are the electron neutrinos. Exactly what CERN and Fermilab want. Muon neutrino, electron neutrino. Showers, shower, muon, muon, and the black one goes around. Now, it's what it is what it is. And here's how it started, and we could see those particles, the green and the red. I'm sure I've shown you. I better show you one more time. All right, these are the red photons coming in, and you don't see anything specific, and they start to make some kind of a change. Then they change into the box, and then the box hits the venturi and explodes. Now, the green ones look exactly the same. All right, there's one just, boom, right there. All right, it's perfect. And it's got these spikes coming down. The spikes start showing up just as it concusses. Now, these want to be glued together. And these want to be glued together. But when they come apart, when there seems to be some chance for sucking some energy out of there. Now, this was my thought, and I might be wrong. I'm starting to think I might be wrong about this. They do break apart, and they do show a tremendous amount of energy increase. But how are we going to suck up that energy? Can we just eat these electrons? And I think we can. And here's what happens. The laser shoots it out. The venturi is here. It splashes all that white shower. Now, the white shower, if we can collect that before it re-adheres to the black, so it's got to be right up close. And only the zillionth of a second is that thing separated. Now, it has 207 times more mass, the black ones, than the white. Can we do any work with this? Will this create heat? I think this is just solid heat, because whenever I've seen this white particles, they just burn. All they do is burn. So I think we can use the MIT heat engine they just made, which is a chip that turns that into electricity. And if we put it close enough up, we might be able to get a ton of electric power. But they're being told not to speak about it. And I was told not to speak about it. I was called a tinfoil hat guy by Fermilab. And I'm blocked from talking to them. They say they won't talk to me. Why not? Here's my email address. Somebody in the government or somebody should stand up. We're paying these people to do this. You know, we didn't pay them for failure. If this has any chance of working at all, I think it's obviously should be looked at. So that's all I'm asking for. It's very frustrating. This 7 years ago I had this up. And you know, even all this stuff I'm talking about goes back 7, 8 years. And it's just been walking around in circles for 7 or 8 years. We could be driving our cars for free. And this stuff is on the shelf right now, all this stuff. There's nothing here to develop. It's just needed to be checked. Can we get more energy here? And I think we can. All right, this is going to be fun. My next video is going to be about plasma. And plasma is another state of matter, which is charged particles. These are the Russians in space. Now watch this. They injected all these charged particles into a vacuum chamber in zero gravity. They're expecting to see a lattice shape where each particle pushes each other away because they're all pushy little particles. See, they wanted to see a clean lattice. Instead, they had this black hole. Watch it. See it go boop, 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 boop. See it? Electron flood theory explains this elegantly. We're going to go through this because they've got some absolutely stunning stuff. Convection currents and all kinds of things, swirling galaxies made with particles because they're in zero gravity. All reactive particles will act the same in zero gravity. They will all push and shove. They're pushing the black into the center, and all the white ones are pushing each other, bouncing, bouncing, bouncing like that. All right, remember you see it? Bounce, 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 bounce. That's what they're doing. They're bouncing until, and then they'll create a stable black hole, literally. Check this out. This is outrageous. Everything I talk about is the white particles push and they shove back, push and shove back. So that means as these white particles swirl, they'll set up interference patterns just like the galaxy does. Watch this. This is stunning. Look, spin it. Let's see it. It's just like the galaxy. It's pulling these particles in, but there's a no man's zone in here. And as they come closer and closer, they get crunchier and crunchier, and the black stuff is going to be pushed into the center, and the white stuff will surround it and get bigger and bigger. A mini galaxy, you see? This stuff is unbelievable. So, but I have a ton of this. There's all kinds of convection current stuff, and this, and then we're going to be seeing water spinning in space and all kinds of stuff. So, very interesting next video. Stick around. But we need to get free energy. We can do it within a couple of months if it works. And I can't really tell you if it will or not. But I think that's going to be enough heat energy. Well, let me show you why I say that. All right, here's why I say we might be able to harvest that white particles. What we had was strictly the white particles coming through the Venturi. So if we could get here and collect those white particles before they ended up getting back to the black particles, we could have raw, solid, burning heat. Because that's what I'm seeing. From an atomic bomb, this is going to be in slow motion. When this explodes, the surrounding the core will always be the white particles. There'll be a ton of them on the outside. They're going to go out first. And we'll see this actually happen in real time. And then after that is the black ones will come following them. They're not quite as energetic, so the white ones hit first. The key is the white ones don't move anything. The black ones are the bombers. Now watch what happens. This is from Atom Central. Teapot Apple II Q House from testing what happens in an atomic bomb. Watch everything here. Every single thing that's here is going to get hit with this white energy. Now I slowed it down to 25% on the speed, and it's also already slow motion. Watch what happens to this house. And I'm going to stop it as it goes along, and I'll tell you when I stop it. All right. I just stopped it. Get ready. Here comes. The first thing you're going to see is just brilliant white. All right, I just stopped it. That's all it is. It's just like a glow of brilliant white. Now, every single thing here is smoking. Everything is smoking. I'm going to start it back up again. Here we go. You see it? It's just smoking. It's literally just smoking. These are just smoking. Nothing's being pushed back here to speak of. It's basically just rising up. You see it? A little bit of a tiny bit of that. Now everything's gone. Everything that could literally burn is now pretty much ash, as far as I can tell. The surfaces, anyway. Underneath, it's boards and so forth you'll see go flying. But all of the surface is vaporized. I mean, literally vaporized. What does that mean? Well, I can tell you, it means a hell of a lot of heat. And if we could turn that heat, anytime you have heat, you can create energy. I don't care what you do. If you got heat, you got energy. Case closed. That's why fossil fuels, you burn them. Anytime you have heat, you have energy. Now, what's going to happen after this? Now comes the black ones. There comes the black ones. I just stopped it again. Everything goes flying. Just ripped everything to shreds, because those are the fixed particles. They're gigantic, and they have a mass, which I said is about 0.000585 atomic mass units. I believe they're 1/1839th of an atomic mass unit, something like that. All right, and boom, out they go. Now, watch happen. It's going to turn around and come back. You see it turn around? Watch. You see it come back? All the stuff is starting to come back. Why would it come back? It's coming back because the black particles are still here at the tarmac. They pushed out all the white ones. The white ones are all gone. But the black ones can't sit there by themselves. So they're trying to pull all the white ones back they can. This is literally gravity. So we just saw everything explained in one shot. The particles, all the white ones go out by themselves. They burn like hell, but they don't have any push. They're just point particles, as Fermilab said 8 years ago, 9 years ago, as I did. And then, I didn't know they were like that, but I could see we could separate them. And then the black particles came and knocked down the house. That's the difference, and everything is made of these two little particles, the two, electron neutrino, muon neutrino. The Bohr model and the standard model completely gone. And it also changes this, because these are not stable. Well, they are more stable at these different periods, these periodicity, these different frequencies, quantities. They shake, and they lock in pretty good and solid. Now, if there's too many electrons, they're shaking, there's still a couple little shakings, eventually they'll kick them out. That's radioactivity. Just too many. And those are called isotopes, which just means you don't have 2,000 or 15, protons together. You have 15 protons plus a couple extra electrons. That's why they're nowhere near a whole nother period. They just have another couple of extra electrons they can't handle. They don't want them there. They say, we don't want you here. Well, I'm staying. No, you're not. Boop, and against it goes. Sometimes there's not enough here, and it will absorb another one. That's called radioactivity, isotopes, stability, half-lives. That's all it is. And there's none of this big, gigantic stuff. All of that stuff relates to all of this little bitty pieces put together. You smash it, they can become stable at these. I'm not saying they're not stable at certain places. Absolutely they are. And carbon is very stable down here because it's in its lattice formation. It's quite stable because it's very low in the periodic chart and it's very dense with electrons. And it has a certain matrix that gives it a lot of stability. Whereas helium and, hydrogen and lithium and sodium and all that stuff, they're not very stable because they have extra electrons sort of hanging around, one here. But these have 7 extra electrons. They want to go and jump on top of one of these. The chlorine wants to hook up with the sodium chloride. So you got table salt. All right, so there's a lot to think about here. Everything's changed, 100% changed, but it's all true. And if you can just walk away from the evidence, then you're not a scientist. And that's what I found. I have found no scientists.